Look on the bottle, what's it say? pH balanced, it says. Some shampoos do a better job at balancing the pH than others do. But that's what shampoo is all about. Shampoo either has a pH very close to 7.6, or the better ones will actually adjust the pH to 7.6, regardless of what the pH of your shower water is.
So is it bad for your hair to like get rainwater on it?
No, but if you took rainwater and took a bath in it, for instance, or washed or just rinsed your hair with it, you might find that your hair is less manageable. Some of us care less about that than others. Okay. By the way, how does rainwater become acidic? Not pollution. Pollution-free rainwater is about a pH of 5.5. What's that called?
Something scary.
No? Carbonic acid. Very good. Where'd you find that name? Did you right there in your acid base table? Hot damn. Okay. Good. And H2CO3 combines with water to make hydronium ion, and the bicarbonate ion. And where do we find bicarb? Where else do we find bicarbonate ion, by the way? I'll give you a hint. It's something called sodium bicarbonate, also known as
Baking soda.
Very good. And of course the bicarbonate ion will also act as an acid to make hydronium ions and carbonate ions. And these are both equilibrium reactions and will go in both directions. It's the reason why carbon dioxide is so soluble. Carbon dioxide is not a polar molecule and therefore should not be very soluble in water. But the little bit that dissolves makes these, and these break up to form these ions, which leaves more room for more of this to dissolve. Okay. All right. We do have problems with pollution sometimes, however. For instance, when we burn coal, this things that you want to get into your notes. Not this one, but the things I'm about to tell you about. When we burn coal, do we burn coal here in California? No. No coal in California. Nearest coal is in Utah and in Arizona. Fairly small deposits of coal. But there's a lot of coal, and I mean a lot of coal, under the Appalachian Mountains. We are labeled from time to time the Saudi Arabia of coal. We could get all of our energy from coal for the next couple of hundred years without importing any oil. We got a lot of coal. Okay? There are environmental problems to mining the coal. There are also environmental problems to burning the coal. One of them is that coal contains small amounts of sulfur. Coal is almost pure carbon. Almost pure carbon. But it contains small amounts of other contaminants, including sulfur. And when the coal burns, guess what else burns? The sulfur. And when sulfur burns, meaning combining with oxygen gas, it makes a combination of sulfur dioxide and sulfur trioxide. This equation is not balanced, it's meant to just describe the processes. together, these things are known as, say it, called SOx. They are oxides of sulfur. The X could be a 2 or a 3. Huh? These are oxides of sulfur. And when we combine SO2 with water, we make that. What's that called?
Sulfuric.
Sulfurous acid. You can name it from the sulfite ion, huh? The ites become us's, don't they? Right? And sulfur trioxide, when it combines with water, makes sulfuric acid. And when would these gases, produced by burning coal, react with water? When it rains, yeah. And it makes what we call
Acid.
acid rain. Heard of it? Yeah. Acid rain is a problem where we burn coal for energy. In the eastern United States, we burn a lot of coal. Most of the electricity produced in the eastern United States is produced by burning coal. But most every power plant in the eastern United States has something called an SO2 scrubber on it that removes the majority, 98% or so, of the oxides of sulfur that are made from the gas that's produced by burning coal.
Should the second version be SO3?
SO3, thank you. Thanks for catching those. We okay? This is known as SOx acid rain. There's also a small amount of sulfur in gasoline, but it's much, much smaller. The SOx problem of burning gasoline in cars is not a very big problem. We have another problem when we burn gasoline in cars.
Of course.
Nitrogen and oxygen gases will combine to form a number of different oxides of nitrogen, such as nitric oxide, nitrous oxide, nitrogen dioxide, and others. Collectively, we call these, can you guess? NOx and NOx.
Mr. Compound, what's the oxygen, how many oxygens are on the last compound?
5.
Oh, 5, sorry.
Okay.
Now, here's the thing. The air is nitrogen and oxygen, isn't it? 80% nitrogen, 20% oxygen. But we don't get these compounds formed in our atmosphere unless there's like lightning discharges. And in that case, since we don't get a lot of lightning, a little bit, it's actually beneficial because plants typically can't use, plants need nitrogen, but they can't use nitrogen in the air. Why not? Triple covalent bond between those nitrogen atoms. Plants typically can't break that triple covalent bond, right? So plants need forms of nitrogen where it's making just single or double bonds with other atoms, like ammonia, for instance. And these are forms of nitrogen that plants can use. So the lightning strikes that occur from time to time around the world are actually good for the biosphere. The problem is, when we burn gasoline in cars, this mixture of gases that's in the air gets sucked into the engine because we need the oxygen to burn the gasoline, and the burning of gasoline inside cars is done at a very high temperature. Has to be burned very quickly because of the nature of the gasoline engines, and because of that, we have very high temperatures. And it's the high temperatures inside gasoline engines that can break the triple bond between the nitrogens and the double bond between the oxygens and make these gases. They're not made very much in the atmosphere naturally, but we make them a lot when we burn gasoline in cars. And what's the problem with oxides of nitrogen? Oxides of nitrogen combine with water to make some combination of nitric and nitrous acids. We call that NOx, acid rain. When we burn coal, we make NOx as well, but they adjust the combustion process in a coal burning power plant so the coal burns at a lower temperature, and that reduces the oxides of nitrogen. So oxides of nitrogen are not as big a problem with burning fuels in a power plant, coal, oil, natural gas, as they are in automobiles. But we have taken steps to add, for instance, a catalytic converter to cars that can cause the oxides of nitrogen produced to get turned back into nitrogen and oxygen. Isn't that nice? So we have dramatically reduced the amount of oxides of nitrogen that are produced by automobiles by using catalytic converters. My 2003 Honda Accord that my wife drives has 3 catalytic converters on them. One of them is devoted to turning oxides of nitrogen back into nitrogen and oxygen. The other 2 are devoted to dealing with carbon monoxide and little pieces of unburned gasoline molecules. But as a result, for instance, the pollutants that 03 Honda Accord puts out are almost impossible to measure. They're so low. If I don't take my car in to have the smog check because Millsburg is outside the Bay Area Air Quality Control District, and we don't have to do that every 2 years like you have to here in Sebastopol. But if I took my car in to a local smog station, it would essentially have zeros for the 3 things that they check: carbon monoxide, unburned hydrocarbons, and oxides of nitrogen. It's not zero, but their machines can't measure it, it's so low. That's cool. I followed a 60s vintage pickup truck, somebody with a green Chevrolet pickup truck up High School Road the other morning, and I could smell it.
That's Eric Foster's.
I could smell it.
Oh my
I
God.
was going up the road behind him. Because that engine has no pollution controls. And because of that, produces about 400 times more pollution per mile than my car produces. 400 times. That's the extent to which we have been successful at controlling air pollution. Dishwasher. I was making that noise.
Nobody dishwasher?
Wait, that's a dishwasher?
So for instance, the air quality in the Los Angeles basin
It's horrible.
is better than it was in 1940.
But it's still really
Can
bad.
you imagine how many millions
Oh,
of cars we have in the Los Angeles basin that we didn't have in the 1940s? You know, the population of the Los Angeles basin probably wasn't even 1 million people in 1940. I don't know what it was, but
It exploded after World War II.
yes, air quality would have been a huge problem in Los Angeles. It's all, the bad news, the good news is that the air quality is better than it was in 1940. The bad news is it wasn't good in 1940. It's ringed by mountains, and when the air is blowing off the ocean, which it typically is, the air pollution that's produced has no place to go. It just stays in the basin there.